Hey, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Welcome to physics. Wow. This is a new year, and you are probably going, I'm a little bit afraid of this class. I hope you're not. But we want to learn together about so much. And so I want to just do a quick introductory video to physics and then talk about one specific topic. But let's talk about this. So much of science is about discovering patterns. So we look for patterns, and let's talk about what those patterns are. So I'd love if you please take notes on these two big things. When we talk about patterns, the two patterns that we want to pay attention to, it's a big idea in physics. We study something in the world. It's a system. We collect data. This is how science works. We explore patterns. Now notice here that they tend to be mathematical models. So we're going to spend a lot of time in this first unit learning about the different mathematical models that the universe follows to better understand the system and then predict future behavior. If you can't predict future behavior, then it's probably not good science, okay? And what are the practices that scientists use? You can see them here. They ask questions, they develop models, they plan and carry out investigations, experiments, they use mathematical models, and they construct explanations. So these are the patterns. This is the big idea of actually really all of science. This is kind of what science is. But in specific, we're going to be looking at, and so don't panic if you're like, oh, I don't get math. It's easy math. We're going to be looking particularly at the mathematical models of science. So in this particular video, our focus is to talk about what is called uncertainty, all right? So how do we handle, this is the big question, how do we handle measuring something multiple times and getting slightly different measurements? And then how do we communicate about uncertainty in those different measurements? So this is the big idea for this video, right? It's the second idea. The first idea is what's science. We got that. The second big idea that we're going to focus on is what is uncertainty. So let's take a look at this slide right here. So science is data-driven. So example here, Ariel and Brock each measure their MacBooks 3 times. They get the following measurements. So you see we've got here 28, 29, and 30, 28.9, 29.0, and 29.1. Those are similar numbers, right? But they're not the same number. So they've measured them with whatever measuring device they have. And the question I want to ask is, how do you communicate about that with the different measurements? So when we have a number, all right, and what you do, and you might remember this back to significant figures from chemistry class, is that the 28 is a measurement, 28 and 29. It's only to two significant digits of the ones place. And then we talk about 28.9 down here, that's to the 10th place. And so when you say a number like 28, it's usually plus or minus 1 of the last significant digit. So what you can say here is you can say, if you have a measure of 28, you're really saying 28 plus or minus 1, because this is a 1 unit. But when we have 28.9 right down here, what we have here, that's plus, that's the 10th place. That's plus or minus 0.1. Does that make sense? So you can say that we know the number plus or minus 1 in this case, and plus or minus 0.1 in that case. So let's look at a couple sets of data. We've got set A and set B, 8, 10, 12, 4, 10, 16. Now you know that one of the ways that you do represent numbers, if they have slightly different numbers, or in some cases large bits of numbers, is to take an average. So if you took an average of these two numbers, you'd add them up, 8 plus 10 plus 12, divided by 3, because there's 3 data points, it's 10. Now uncertainty is a little bit different. Uncertainty, we're going to use something called the range, or the uncertainty in the average is the range divided by 2. All right, and the range is the biggest number minus the smallest number. So in the example of set A, that's going to be 12 minus 8. 12 is the biggest number, 8 is the smallest number. Divide by 2, that's 4 over 2. That's 2. So the uncertainty here is plus or minus 2. Now, hopefully you realize that the second set B right here, it's 16 minus 4. So let's write that down. 16 minus 4 over 2, which is 12 over 2, which is 6. So this set is plus or minus 6. So when you're talking about uncertainty, this idea of range really makes sense. So if you've got a series of numbers, how confident are you that these are good representations? Well, you can only say plus or minus 6 for set B. For set A, because they're more clumped together, you can say plus or minus 2. So to review, uncertainty, while we record a single value for your measurements, we acknowledge that our measurements will not be exactly the same, but likely always be within a certain range of recorded values. The rule of thumb is the last significant figure is uncertain. So the last number is uncertain. We don't know if it's 8 or 9 or whatever, like we had that 28 and 29 earlier. Uncertainty is one significant figure. And then you record your measures and match the uncertainty. And remember, the uncertainty is the range over 2 if you're averaging. So that's going to be our general rule, is that if you have a series of numbers, you're going to find their average, find the range, divide by 2. And you can then report the numbers that we think the numbers between this and, or you just say plus or minus that number. And so like if you end up, if you get 28 is your average, and you say plus or minus 2, what you're really saying is it's a number between 26 and 30. That's all you can say. And that's the big idea of doing uncertainty. Next up, you're going to do a couple of worksheet questions to help you just cement this. But other than that, hey guys, welcome to physics. You guys are awesome. I think you, I haven't met you yet. And I know you will be because you've always been, because our students are great. Hey, Houston, we don't have a problem.